Hey, let's do an application of parallel vectors or vectors that have the same direction. Okay, here it is. Okay, so this looks really confusing, right? We have 2k minus 1, and k here is not a vector, it's just a constant numerical value, times by a equals 4b, given that the magnitude of b is double of magnitude of a, then what's k? Okay. Now remember, parallel vectors or something like this. So these two are parallel. For example, if this was vector u and v, and let's suppose that this is the half the length of this, then we can say vector v is equal to double of vector u because they have the same direction. And doing this will make their size. So if you have u and one more u, so 2u, look, it's exactly equal to vector v. You can only say a vector is equal to some multiple of another vector if v and u have the same direction, okay? Equal direction. If they are at all different direction, right? Even if they're the exact same size, there's no way they can equal, okay? Some k times by b if they have different direction. So the fact that we see a vector is equal to another vector, this implies that A is parallel to B. Okay? All right, so let's take the magnitude of both sides. So now we know they have the same direction, A and B. So if we take the magnitude of both sides, so magnitude of 2k minus 1, magnitude of A, 4 times magnitude of B. Okay, this should also equal because we already know they have the same direction. Now in this form, okay, because of the fact that they're parallel in this form, now we can replace B B with 2 of A. Now this absolute value symbol here, that means we just care about the magnitude. So they're numbers. These are numbers, not vectors. Numbers. So we can divide both sides by A to get 2k minus 1 is equal to 4 times 2 is 8. That means 2k minus 1 will equal to either 8 or minus 8, right? So 2k is equal to 9 or minus 7. So k is equal to 9 over 2 or minus 7 over 2. Okay, for these two values, this statement will be true. Okay, so like I said, it's an application. It does require more thought on what it all means. All right, I'll see you in the next one.